Alright, surface area. Surface area can be really helpful if you want to find out how much wrapping paper you need to cover a present, or how much paint you need for a room. So the surface area, or I'll abbreviate it, SA, is just the sum of the area of all of the faces, including the bases. So imagine if this rectangular prism represents a room, and we wanted to find out how much paint we needed. We'd have to paint this side, this side, this side, this side, and then the ceiling maybe, but not the floor. So we would find the area of all of the faces, including the two bases, but we probably wouldn't want to paint the floor. Now the lateral area, abbreviated LA, is just the sum of the area of the lateral faces. And just a reminder, sum in both of these instances means plus. So you're just adding up all of those areas. So the lateral faces are just the ones around it. So here we would have 1, 2, 3, 4 lateral faces, and we're not including the bases. Here we would have 1, 2, 3, 4 lateral faces, and we would not include the bottom base. So surface area includes the area of the base, lateral area does not. Now there is a shortcut. The shortcut is you just take the lateral area of a prism as just the perimeter times the height. So for instance, instead of finding this area, this area, this area, and this area, we could just find the perimeter of that bottom face there and multiply it by the height of the prism. So that can definitely save us a little bit of time. And I want to go ahead and prove that that works. So let's say that this was 6 and this was 3 and the height is 4. So just to show that that works, the perimeter is going to be, well, that's 6 and 6, this is 3 and 3. So 6 plus 6 is 12, plus 3 plus 3 is 18. So the perimeter equals 18. And then times the height. So we want to do, again, lateral area was P times H. So we would do 18 times the height of 4. And 4 times 18 gives us 72. Now to do it the longer way, we could just find the area of this rectangle, which is a 4 by 3. So that would be 12. And then the other side is going to be 12, because it's a 4 high and 3 long. And then this front face, it's 4 high and 6 long, so 4 times 6 gives us 24. And then the back one's the same way. So if we add up 24 plus 24, we get 48, plus another 24, 58, 68, plus 8, plus 4 would be 72. So yeah, that would work. So if we added up all 4 of those, 12 plus 12 plus 24 plus 24, we still get 72 for our lateral area. So that shortcut does work. So if you like it, use it. Alright, there's another shortcut, and that's for surface area of a prism. You just take the lateral area, which we just found, perimeter times the height, and then we add 2 times the area of the base. And that's what B stands for. Let's define that. Capital B is different from lowercase b. Capital B is the area of the base. If it's a lowercase b, it just refers to the base of a two-dimensional figure. So for instance, this is the base of the triangle, whereas this whole square in this case represents the base of the whole figure. So we would use capital B to talk about the square of the rectangle here, but we would use lowercase b to talk about just that side. So again, capital B would be the whole thing, the area of the whole thing. Lowercase b is just for that one little side. Alright, now a cylinder is 2 circles and a rectangle. And the rectangle's length is the same as the circle's circumference. Let me show you how that works. So, just drawing a cylinder, just like a can of soup, You have two circles, and then you have the curved surface. Well, that curved surface, if we extend it out, think of like a soup label. If we extend out that soup label, it's going to make a rectangle. So if we unwind it, it's going to look like this. And then we still have that circle on top and that circle on the bottom. And what I want you to see is that distance around that circle. When you unwind it, it's the same as the perimeter, also known as the circumference of the circle. It's called circumference because it doesn't have sides. So that's the same thing. So that bottom part is pi d. The top part is the height. So that rectangle has two dimensions. Pi d represents the base of it, or the length, and then h is our height, or the height of the cylinder. So let's look at it. Let's say that the radius here is, let's say it's 2. Let's say the height is 4. And let's say that's all we know. And the question is, find the surface area. So if we're finding the surface area, we just need to find the area of each of the circles and the rectangle and add them together. So in simple terms, the circle is going to be a equals pi r squared. Remember, apple pies are 2? So I'm going to plug in for that. It's pi times the radius, which is 2 squared. So I get 4 pi is the area. And that's about 12.56. That's the area of each of my circles. Alright, now all I have to do is find the area of the rectangle. Well, I know my height is 4, so I'm going to plug that in over here, because that's the same as the height of the cylinder. But I don't know what this base of the rectangle is yet, but I do know it's the same as the circumference. So I'm going to do pi times diameter, cherry pie, delicious. And my diameter is 4. So I'm going to do c equals pi d, and do pi times 4. And then 4 pi is the same thing as what we just found earlier. It's 12.56. And a common mistake here is to say, oh, the area is 12.56 of the rectangle. Not the case. The area is, for a rectangle, the formula is base times height, or length times width. So I need to do 12.56 times 4, and that'll be the area of my rectangle. And that's 50.24. So now my last step is just to add up these three numbers. So I'm going to add up adding up 50.24, 12.56, and 12.56 gives me 75.36. And that would be my surface area. So what is the formula for the area of a cylinder? I'm going to go ahead and say that the surface area of the cylinder is, how many circles do we have? 2, right? And what's the area of the circle? Pi r squared. And then what do we add on? We found the circumference times the height, right? So it would be pi d times h. And that's our surface area formula of a cylinder. And then the lateral area would be the same thing, except we don't use the bases. So what are we not going to use from that formula? The 2 pi r squared, right? So we would just use the circumference times the height, so pi dh. Alright, and that wraps up cylinders. Alright, now the lateral area of a pyramid is 1/2 the perimeter times the slant height. So L stands for our slant height. And that's very important because height and slant height are totally different. Height would be the perpendicular line drawn from the top to the center of our figure. And you would need to see a box there to show the right angle. That's our H, or our height. Now our slant height is this thing. It's the line drawn, or the height of the triangle. So those are two totally different things. So that's our slant height. So hopefully that visual helps it out. Slant height's slanted, and then the actual height is perpendicular to the base. And the surface area of a pyramid is the same thing. It's the lateral area, but we have one base, not two bases. So you would just find the area of the base and add it on to, and you could do this the long way. This is just the shortcut, the perimeter times the slant height. You could find the area of each face and add them all up. It's just a little more time consuming. Now the lateral area of a cone is the same, except we don't use the letter P for perimeter. We use the letter C for circumference, because we talk about circles using circumference, not perimeter. But it's essentially the same thing. So we're just going to do 1/2. I'm just going to show you the work for this. It's 1/2. Circumference is pi d. So 1/2 pi d times the slant height. And half of the diameter is really just what? The radius. So this formula is really just pi r L. And that's the lateral area of a cone. It's just pi r L. I just wanted to show you how we got that. So it's the same thing as circumference, half of the circumference, which is the same as half of the perimeter. So these are the same formula, but half of the circumference is really half pi d, half of the diameter is the radius. And that's where that came from. And you know the surface area would be the same formula as up here. It would be the lateral area, so pi r L, plus the area of the base. And the base is a circle, so that would be pi r squared. Alright, last formula to talk about is a sphere, just like a basketball or a soccer ball. And the surface area of a sphere or a basketball, or any round object for that matter, is 4 pi r squared. So it's the same as the area of one circle, but you just multiply it by 4. So pi r squared times 4. Alright, now that we've covered all our bases and we have all the formulas down, let's apply it to an actual question. Alright, here's our application. How much paint is needed to paint the figure? And if you write that question down, I want you guys to try to draw this picture with me. So just draw an oval, and then another oval, and then connect them, and then make the last one into a cone. And then I went ahead and made a couple dotted lines on the right side of each of those ovals, because they're behind the figure. Alright, now let's fill in a couple of the sides. I have 3 centimeters as the top. The slant part of the cone is 5 centimeters, and then the radius here of the circle is going to be 4 centimeters. And now we have enough information to figure it out. But I want you to think about the game plan. So rather than this thinking of this as one cylinder and one cone, it's a cone that's attached to a cylinder. So what would we really be painting here? Well, we'd paint this base. We'd paint the lateral area of the cylinder, but would we paint this base? No. We wouldn't, and that's part of the cone and part of the cylinder, so we would not paint that, but we would paint the lateral area of the cone. So our game plan, let's jot that down. So our game plan is find the lateral area of the cylinder plus one base. Remember, just this base, not that one. And then the lateral area of the cone. So we're ignoring this base in both occasions. So the lateral area of the cylinder is just going to be pi dh, and then the area of the circle, which is our base, is pi r squared. We only have one of them. And then the lateral area of the cone, well, we just talked about that one. The lateral area of the cone is just pi rl, so we're going to add that to pi rl. So now we have pi times, our radius is 4, so that means our diameter has to be double that, which is 8. So that would be 8 times our height, and that's referring to this number up here. That's the height of our cylinder, which is 3. And then plus pi times the radius, which is 4 squared, plus pi times the radius. Then our slant height of the cone is going to be this 5 right here. Now I'm going to simplify that. So think 8 times 3 is 24, that's 24 pi. And then 4 squared is 16, and that's 16 pi. Notice I'm doing all the multiplication first before I add. I'm doing order of operations. 4 times 5 is 20, that's 20 pi. And now I can just combine all my pi's here. So 24 pi plus 16 pi, that's 40 pi, plus 20 pi gives us 60 pi. And 60 pi is the same thing as, if I do 60 times 3.14, it's about 188.4 centimeters squared. So either answer is good. If they want the exact answer, it would be 60 pi. The rounded answer would be 188.4. Alright, great job finishing that out. And now you're all set. Surface area is just how much space is on the outside of a figure. So like wrapping paper or painting. And on second thought, how about you buy the present and I'll wrap it?